Last video brought to you by, I believe this is Damaged Darth Vader. So here we're going to sketch a reference angle and we're going to find all of these exactly. Note these things are a little bit problematic here because root 3 over 4 is not one of the ratios we know to be in the unit circle. And if you're wondering what in the world I'm talking about, I'm saying when you look at the unit circle, the x and y values that you see in there are these in this order. 0, 1/2 root 2 over 2, square root of 3 over 2, and then 1. And don't forget -1 and the negatives of all these. So we smash those in there. So whatever, just this and then their opposites. Those are all the possible x and y coordinates in the unit circle. And then we could like flip them and divide them to get the tangents and the other ones. But this is not one of those ratios in there. However, we know what this thing means. It means tangent of some angle equals the square root of 3 over 4. And then we know that if we were to draw a right triangle, and if I put theta here, then tangent of theta is defined as, now this is old school, this goes way back to chapter 6, it is adjacent, opposite over adjacent. So this would be, or you could think of it as sine over cosine. So this is the square root of 3 over 4, and we have some unknown, let's call it r, because if this is in the unit circle, it would be a radius. So r is going to equal, let me try that again, r squared is going to equal the square root of 3 squared plus 4 squared. So that's 3 plus 16, which then is 19, r squared. So r equals plus or minus the square root of 19. The question is, should it be positive or negative based on where this is in the unit circle? So let's see. Since we know this is just some sort of theta, we really know that this is saying cosine of some theta, whatever it is, we could use our calculator to find it, is going to equal something. But we know cosine itself is defined as the adjacent over the hypotenuse. So this is 4 over plus or minus the square root of 19. All we have to determine is which of these two values should it be. Well, here's how we do it. Recall that the outputs of tangent are all the values between negative pi halves and pi halves, not inclusively, right? So it can't be negative pi halves, nor can it be pi halves, but any value in between there. So if you look at this, that means we're fixed in the first and fourth quadrant. Well, what are the cosine values in the first and fourth? They're all positive values. So we have to ignore this. The other thing to think about is because this is a radius in a unit circle, then it's going to be that positive 19. Either way, we know our final answer is 4 square roots of 19. Now, if your instructor demands that you rationalize this, which is a perfectly reasonable request, it's an arbitrary request, but whatever, it would be 4 square roots of 19 over 19. That would be your final answer. So let's try this with another one. Again, note, what we're really asking here is what is tangent of some angle value? And this angle, which maybe I should have written this out explicitly on the other side, is this. Well, what this represents is sine of some angle is equal to 0.1. Now, I could write that as 1/10. And then I could draw my right triangle. Swoop, swoop, swoop. There's that. There's this. Sine is defined as y over r, or opposite over hypotenuse, so we could write it as this. And then we could say, what is this length? Let's call it x just for fun. So x squared plus 1 squared equals 10 squared. So x squared equals 99, because I subtracted 1 from both sides. And then x equals plus or minus the square root of 99. Note this is 9 times 11, so this is really plus or minus 3 square roots of 11. That's what this is. So let's think carefully about how sine is defined, sine inverse. What are the possible output values? So I'll draw the first and fourth quadrant are the sine values. And let's see, so sine, this quotes x value, or this value in our right triangle, could be a value here, or it could be a value here. We don't quite know at the moment, or maybe we do. I just haven't come up with the argument for it yet. So let's go ahead and write tangent. So tangent of this angle, this triangle applies to tangent, is going to be the opposite value over the hypotenuse. So that's, again, plus or minus 3 squared is 11. So we have to come up with an argument as to which one of these could we ignore. Well, if you look back at what sine inverse was being taken of, it was a positive 1 over 10. That means it has to be a positive x value. This has to be positive because we're in the first and fourth quadrant, and the negative part would have been taken up by this. So we can ignore the negative value in all of these and note that it has to be the positive value. Now, we can rationalize this by multiplying by root 11 over root 11. I think my math lab is going to demand that of you. So you have the square root of 11 over 3. That's it. There's your exact value. Okay, we got two more. So, oh boy, aren't these fun? Notice we no longer have values here for both. It's an expression now. So we'll do our same line of reasoning. We know that tangent of some angle theta is going to equal a over 3. That's an a, not a 9. And then what this is going to become is sine of that same angle within a right triangle is going to equal something. So let's build our right triangle. Here it is. We'll make this theta. Tangent is defined as opposite over adjacent, so a over 3. So we'll use the Pythagorean theorem to find the hypotenuse, which would represent the r in a unit circle. So that's just 3 squared plus a squared equals, we'll label that as r squared. So r equals plus or minus the square root of 9 plus a squared. Okay, so remember the outputs for tangent inverse are negative pi halves to pi halves. So both of these values could happen. All right, so when we do sine of this angle, it is going to be the opposite, so it's a over the hypotenuse. So the ratio here for this thing is a over plus or minus the square root of 9 plus a squared. So we need to come up with an argument of why that square root of 9 plus a squared has to be positive. And the answer is, it's a radius or it's a hypotenuse. That is never negative. Unit circle, you always consider the hypotenuse positive. So the negative part would have to be either the a or the 3. Well, the 3 is not negative, it's positive. The a value could be the negative or the positive. So we ignore this, and we know our final answer before we rationalize it is this. If we want to rationalize it, multiply it by the square root of 9 plus a squared over the square root of 9 plus a squared. In other words, multiply it by 1. And we get a square roots of 9 plus a squared all over 9 plus a squared. That is what my math lab is going to work with. If you were in my class and taking this exam, I would be perfectly happy with that answer. Okay, one more. So again, all of this inside here represents theta. So our job is to figure out what's cotangent of theta. And what we're noting is that sine of that same angle theta is equal to some p divided by q. Well, draw your right triangle. Ooh, let's get some lines of division here. Build that wall, right? Here's the right triangle. Here is our theta. So the opposite of theta is p. Sorry, that was a terrible joke about the line. Ignore I said that, please. And the hypotenuse is q. So we have to figure out what is this. Let's call it x just for fun. So we're going to say that x squared plus p squared equals q squared. And then there's really nothing we can do with this other than take the square root of both sides. And note, anytime you have an unknown value, it's plus or minus. So because this is an x-coordinate value, this could be either the positive or the negative. We don't quite know, except when you look at the possible outputs for sine, inverse sine, they are only values in the first and fourth quadrant, so this has to be a plus based on this reality. So we know exactly what this is going to be. Cotangent then is, it's just it is the adjacent over the hypotenuse. So this is going to be the square root of x squared plus p squared, all divided by p. There's your final answer. Wasn't that wonderful? I guess I'll go ahead and tack on this last problem, and then we'll be done with 7.4. So we got an airplane is flying at an altitude of 2,000 meters towards an island. So here's my stick figure airplane. This is the ground, and this is the distance between the ground and the plane, 2,000 meters. That's altitude. It's headed towards an island. The straight line distance from the plane to the island is m meters along a specific angle. So let's call this the island. And we're going to do the straight line distance here to be this, and is m meters. So we could turn this into a right triangle. And let's see, where theta is the angle of depression. So angle of depression is the angle between the horizon and going down. So this would be theta. Using your geometry skills from high school or wherever you got them, that would also be theta. We're going to express this angle of depression theta as a function of m. Whenever you read this language, that means we want f of m equals something, meaning we plug in the m, it spits out, in this case, theta, an angle. Well, let's see. We know that this would be the opposite side. This would be the hypotenuse, and this is our angle. So there's a trig function that will relate these three things. And opposite over hypotenuse sounds like sine, right? So we know sine of some angle theta equals 2,000 over m. Well, if I solve this for theta, I will have it in a form of theta equals something, and then I can rewrite it as f of m. So all we have to do is take the inverse trig function of both sides and say, what's sine inverse of 2,000 divided by m? That would be the deal, and we could rewrite this as our input is m. Note that's all that's on this right side, and we'd have sine inverse of that input m. And we know what this spits out. It happens to be the theta. We just replaced theta with f of inverse, and now we've done what it's been asked.